Yes. Um, Thank you all for coming. I tried to make it as practical with Johannes today as possible, and I'd like to show you one very specific example where we already experience generative AI in the software development process, and Johannes is basically doing the same thing but explaining a few more basics and concepts and models actually how to do this.
Yeah, and we're together with MaibornWolff and Seerene because we are in many customer situations we are jointly active. Um, MaibornWolff with many, how many employees?
Like 1,000 now,
Yeah,
1,000 please.
so they have a lot of human experts when it comes to all kind of technology issues close to implementing things, processes in software development, and nowadays Gen AI based using Gen AI tools the right way. And we as Seerene with our AI analytics platform, we are able to measure big software development organizations, so we have the capability to see what's going on or to make visible what's going on also to management level. And this together has brought us into many customer situations where and now specific with that question, where are the teams already making use of that powerful tools? Because we see that in the numbers, in the KPIs, in the seismographic activity of the analytics, of the data in the software development. And then together, with the experts helping the organization to do it the right way or to broaden also the use where parts in the organization this is not yet a tool. And now in the talk, as you said, Holger, right? First, an example where where Gen AI is actively being used, and then I will take on somehow building on what Jürgen said, where we foresee Gen AI to be the next building block in the software development chains.
Thank you, Johannes. I would really like to connect with Jürgen, what Jürgen said. We are still early. We are still early in this process. We, as MaibornWolff, as developers, we are still responsible for the code we deliver. So we have to understand the code, and it has to be human understandable code that the AI produces. And we have to check the results, and we have to verify the results, and we have to ensure everything is proper. This is right now our legal responsibility, and it's our technical responsibility, and it's our moral responsibility. That might change in the future. Actually, for us, it has already de facto changed with open source. Because if we use Apache frameworks today, we technically could check the code and it's human readable, but no one ever does it, at least none of our developers. So we have like 10% of MaibornWolff written code and 90% cloud APIs, open source software from Microsoft, from hyperscalers we use, which we never check anyway, and where we rely already today that it works. That's going to change in the future probably, but for the next steps in this process, we still have human understandability of the code that is produced through AI as a basic prerequisite for us to be able to use these technologies. At MaibornWolff, we expect not to need fewer software developers, but more designers, project managers, and requirements engineers in the future. Because we already see that the bottleneck that has been the software engineer and the scarcity of software engineers for the last 40 years is actually moving towards design, digital design, requirements engineering, understanding the requirements, project management, and people who are able to really implement end-to-end solutions with the customers. So we've started a couple of years ago to employ more designers, more digital designers, more requirements engineers, more business experts, more project managers, and this trend is actually continuing because we don't need less developers, but we need more actually of the other kind to get these solutions into practice. I would say the software crisis is over. The software crisis is an official term that was framed 50 years ago at a NATO software development meeting in Garmisch, because then it became obvious that the increases in hardware performance would outpace the increases in software performance for decades, and the term software crisis was framed because there was never enough software knowledge actually in the market. I think we are close to a point where we could say the software crisis is over. We will have enough resources to write 5 times more, 10 times more software than we have been able to write in the last couple of decades. And that's good news, actually, on one hand, but it's also bad news because we need more people to manage the new complexity. An average company will have 10 times more lines of code under management in 5 to 10 years than it has today. And this is also where Seerene comes in, because that complexity of software has to be managed somehow, and it's impossible to manage manually. You need the complete Seerene tool stack actually to be able to manage such a complexity of software in your daily operations. I've also seen, this is more a bit research, I've also seen fantastic first steps into assisted requirements engineering. We have some ex-employee that founded a startup called SendData, and they focus on AI-based requirements engineering. And I mean, it's yet simple, but we did like an application for a match of tennis partners, and we entered the basic requirements we had in 3 sentences, actually, how a tennis partner matching app could look like. And through 2 or 3 questions, the SendData actually implementation of a large language model then created a data model, created the code, created the user stories, created the test cases. And it was really impressive. I mean, obviously that's not going to work yet for complex business applications, but it's a glimpse for us on how even requirements engineering and digital design will be assisted by AI solutions in the future, and will help not only software developers but also requirements engineers and people who design a solution to use these models in practice. Now, one specific example that I mentioned, I would like to show you. We did for one of our large OEM customers a migration from one Java framework called Pajira to Quarkus. Quarkus is like the newer version that you want to use today, because it's cloud native, it has a much better container support, it works better with Docker and Kubernetes, and you want to migrate your legacy code in Java actually from Pajira to Quarkus. And we've done this with a very large Java-based production system from one of our automotive OEMs. And we had actually made an estimation about the effort if people would have done this manually, like in all the years before. And the estimation for that project was 200 man days. So we suggested it would take 200 man days to migrate this code to Quarkus, and it would have been like 4 people for 50 days each. That was like the estimation for that. In the end, we managed with an AI-assisted migration approach to cut down that estimation by a factor of 10. So we needed 20 days in the end to do it AI-assisted, including preparation, including concept, including testing, including verification. This is a very optimistic, actually, understanding, because it was a relatively simple task, because the framework is well known, it's well documented, LLM knows it, and so on. So that's not going to be suitable for all kind of technical migrations. But we would estimate that a factor from factor 3 to factor 8 should be actually achievable in most migrations settings that we have today. It solves actually a major bottleneck, because many of our customers still have tons of legacy code in their organization. And that puts you in a problem, because you usually don't have enough budget to do both at once, like migrate all the old legacy code that you want to have on a new platform and implement all the digitalization solutions you need for today's business. So that leaves you with complex decisions. And I think the AI-assisted migration is probably one of the most promising ways to use AI in daily business today. So what did we do? First of all, we needed a basic instruction and a cookbook. And the basic instruction, really, this is from the original project, was don't remove any comments. Remember that the examples in the rules just help you to understand the rules. Your response must contain the complete uncut migrated Java class and respect the cookbook migration rules. That's important, because otherwise the LLM comes with some fancy suggestions that you then can't control and can't verify. And you really talk to the LLM like you would actually talk to a junior developer. So you explain the LLM what the task is as you would explain it to a junior developer. So step 1 was the general rules. Step 2 was we wrote a cookbook. And as I said, the cookbook actually has a set of rules on how we want this migration to be done. And this is also a documentation from the original project. So the text we wrote is the cookbook we actually gave the AI. And you can see that we gave very specific instructions on how we wanted this migration to be handled. Of course, and this is also what Jürgen said, this is a very complex task, and it requires senior developers with a lot of experience, because you have to anticipate what would actually happen in this migration, and you would have to write a cookbook in advance to tell the LLM basically what to do and how to process the code in detail. Then that's actually how we did it in detail. First, obviously, you create a migration branch, then you do the AI-assisted migration, then you review the code, and then it's an iterative process, because then you detect some irregularities and some errors and some things you have a not desired outcome. And then you update the prompt and cookbook actually again. And we did this like 3 or 4 times until we got the desired solution. Then we had at 6 or 7 points in the code, we still had to do some manual changes, because we saw that the result from the AI didn't actually work in the way we did even with the cookbook. Then we did a second human code review, and then we merged the code back into the production systems after extensive testing. The results, as I said, the whole project took us 20 man days. The estimation to do it manually, it was like 100 large Java classes that were affected, and the manual estimation would have been 200 man days, so it was factor 10 more efficient. The developers in this project were actually very happy. I often get the question if developers oppose these kinds of technologies. In my understanding, they don't, because no one loved repetitive work anyway. I mean, it's not really a desirable task for a senior software developer to write manually a Quarkus migration in a system with a few million lines of code, find the places where it is, migrate it, write the code manually, check it in, test it again. That's not something developers love anyway, so the developers were actually very happy. And the third understanding was, you still, at least for the foreseeable future, you need very skilled developers and architects, and AI, at least for us, and at least not today, and at least not for the next 5 years, is not gonna replace the need for software engineers and actually the need for architects. In our customer base, we have tons of legacy systems. We have hundreds and hundreds of million lines of code in Delphi applications, in Oracle applications, in stored procedures, in Java applications from the early 2000s, sometimes in COBOL applications. And I mean, the last 10, 15 years have usually not done much with this legacy systems because it was always very hard to justify a business case. I mean, if you do like a one-to-one migration from an old Delphi system or from an old COBOL system or from an old Java system, you don't really get much benefit, and that usually didn't make it through the ROI calculations from controlling. That's going to change. So in the next 5 years, I see a massive disappearance of old legacy code because the migration of old legacy code just became so much easier now with the tools we have.
Yeah, I have it. Yes,
connected.
perfect.
Okay.
Yeah, so this was a very hands-on example of where GenAI helps a lot today already. I do a little step back. Recapitulating the evolution of software production, where the GenAI aspect fits in, and yes, the answer to that question would be yes. It's a new era starting now. In general, software development is all about languages, right? It's you have some kind of word problem, and you as a developer or developer team, you need to find a solution and express these solutions in the language of the machine. This was initially done in machine language. I don't know who of you already still knows assembler. Yes, but understanding this program is quite tricky. Writing this is even more, and this is a very small task, like in these lines. So what you needed there was highly skilled developers and with the specific intellectual knowledge of doing this translation gap from human language describing the world problem into code on a machine level so that the machine understands it. The next big facilitator was the compilers, which is a generator for code that is being understood on machine level, and so that developers could express their thoughts in a high level language, like C, for example. Here, this program here shows like some few lines solves how to convert Fahrenheit into Celsius temperature degrees, right? So it's a small problem, but writing this into in assembler would, I don't know how many days, weeks you would need to program that. So that was a big step forward, and generally it also enabled to work collaboratively. because now you have functions that you can name with world language names, and you can reuse them. So this was actually the starting point for solving big world problems. And the next thing, and this is now something which happened in small steps, so not this this big disruptive thing what's happening with GenAI. This is now towards decades. And for example, and it's about reuse. It's about frameworks. If you're a good Java developer, you're not a good Java developer because you know the Java syntax. You're a good Java developer because you know the Java framework and all the solutions that are there. You know which kind of APIs to call, which kind of functions and classes to take. So it's about this reusable knowledge, and all the open source theme is on top of this, right? It's like integrating into these frameworks. So that means that it's possible to build the big business applications, to build the smart things, because you have that big fundus of reusable code. And now, but still a highly intellectual task to convert the world problem in human language, because it comes from business side, into this high-level programming language. Still a huge gap to translation gap. And this is now where GenAI will be, is already and will be a big help, because now you can express your problem domain in the human language, right? Here I did this some days ago for that talk. Did I have it here? I didn't show that. This code up here, this is that's astonishing, I think. Like I just said with Fahrenheit to Celsius conversion, right? This amount of code. The same amount of code is for ramping up a web server on a computer, having all the network TCP connection established, so that another computer where a browser runs gets a web page, right? In just these few lines of code. So it's still amazing, I think, because of that reusable frameworks and libraries which are there. And actually, I didn't write it by myself. And you see, right? It's still some technical knowledge that you need to have to write this. I didn't write it. I asked ChatGPT. Just with a normal sentence, create code for web server, initial homepage shall be shown with the company logo and the text, welcome to our company website, and whoop, I had it. So it really speeds up development, because it makes use, and you ask it, right, it makes use of all the human knowledge that has been pumped into these big code bases, primarily GitHub, because open source, everyone can use this, and the LLM can use that. And so this is a big step forwards, and means that developers shift more and more towards, as you said, Holger, shift more and more into the domain, or can shift more and more into the domain, and get rid of this stupid part of coding, and focus on the
I said the
repetitive. Okay, yeah, good, better word for that. Yes, and boring also for some kind of developers. They don't like it. But so this means a big boost in productivity. But at the same time, and this is very important, there is big risk behind it, and what should not be expected is that here there are the developers as prompt engineers in the middle between the business, the word problem, and the code that is being produced, or the prompts that are being produced. And it will take, I don't know how long it will take, but it will, for the next upcoming years, these developers and highly skilled developers here are necessary. Why? Because if you would give that directly to someone on the business side, and this person would write the prompts and the code would be produced. There would be a missing piece, which is the technically highly skilled people who check this, so to oversee that. And there are multiple risks. One risk, for example, would be that you change with the prompt a large portion of an existing code base, and you cannot assess the risk towards side effects, etc. Right? There's the risk of that the GenAI produces code like coming from genius developers, like in the early C programming where you had the entire algorithm in one code line. This was genius and perfect for that case, for that person, but if the person was a way totally not maintainable code, and you had to rewrite everything. And these kind of complexities can come into the code bases with GenAI. Actually, that's what we see also, because we detect, we see what's happening in code in software development organizations through all industries, and we see that if it's not used in a good way or in a highly skilled way, there's some complexities coming into it. And just in this example, what I did 1 minute later to produce that code for the web server, right? 1 minute later, the same prompt, the same ChatGPT-4 model, another output. And first it took Node.js with Express in it, and then it took Python with Flask, right? It's like an arbitrary choice and non-deterministic, even if it's the same model. And these models, it is being said that they are kind of stable, but even then, because they are now experimenting with, do you like this result more than that, to get some user feedback. I don't know if you've experienced that already. So they experience, and in future these models will learn on the fly. So there's no ground truth. There's no deterministic way. So what you need there is the human, highly skilled developer in the loop to make sure that you do not include these kind of risks. And very complex picture now, because initially I reduced everything to developers, but software production is much more, as you better know, right? Because it's a daily business. It's about the transformation from requirements to work items, to coding, to some CI/CD pipelines, like converting code into some executable, to check the code, to check the runtime, testing, etc. And then it goes into the machines or the servers or into the car, right? And Seerene takes data from all these different tools from the entire tool chain. That's how we are able to measure what's happening in software development organization, and show also and do a translation from technical code related things and coding related things into management relevant things, like efficient use of developer time, like only bug fixing, or really creating value add, which is management relevant information. So we see what's going on, and in the times of GenAI, here the developers are replaced by GenAI bots, but being controlled by and fed in by engineers as prompt engineers. What we see is that if this is happening in parts of the software development organization, it's much more code produced in shorter time, which is good, productivity, but at the same time, it also sometimes creates a lot of unnecessary complexity and future risk. So it's definitely necessary to monitor this and to have an eye on that, and also to help then these people to use these powerful tools in the right way. And and this is actually what we see across all domains, let it be telco, but automotive and embedded is a little bit cautious here still, because safety critical parts, you don't give it away to just GenAI. In others, they are a little bit less safety critical, so they can experiment easier. But we see these effects, and we strongly recommend to have a management focus on that and to handle and steer that transition to the use of GenAI in a managed way, actually. And in the break times, I'm really interested in how you already steer that transition towards GenAI-based code production.
Thank you, Johannes. I really think this is a very important point, and we see it at our customers every day. So if you haven't talked to Seerene, you should use actually the coffee breaks to do so, because it will just be impossible to manage billion lines of codes that you could expect for your organization in the future without a management platform that is actually capable of doing so. It was just impossible. We have a very promising joint project actually for BMW, and the example I showed you also is also from a BMW production case. And I see more and more customers getting interested in a very strategic code-based management, because it has been optional in the past because you had like a few million lines of code. But if you have a few billion lines of code, generative AI generated code in the future, it will just be impossible to manage that code base somehow without a good procedure and without a good set of procedure and without a good platform that is actually capable of doing so. Are we open for questions, Johannes?
Yes.